The task is to find such function f defined at the interval between -1 and 1 that satisfies the following equation. The main problem here is that we are not provided with any hints regarding the form of this function. For instance, where it's a polynomial or another trigonometric function. No clues, no hints, nothing!
Clues, no strategies, no options, zero, zip, nada. No trust. Liar.
In that case, let's go to a very core definition of a function. Roughly, we can define a function as a relation or a rule that associates each element of the first set x to a single element of the second set y. The rule is named, for instance, f, and elements of the second set are often named f of x. Therefore, now it's clear that in order to define a function, we should end up in the form like this, where we have f of x on the one side and the expression depending on x on the other side. Note that right now, neither of these conditions met. Arguments of f are different and we have f at both sides of the equation. Let's solve these problems step by step. Firstly, let's work with the arguments of the function. Since the given equation should hold for all real x, it should also hold for the other arguments, like pi divided by 2 minus x. For this argument, our equation will have the following form. And by using the basic properties of sine and cosine, we can simplify this equation to this form. Now, we can recall the original formulation of the math problem and use it to rewrite f of cosine x. In this way, we have a right to the form when arguments of f are the same, and now we can rewrite this equation to have the function f on one side of the equation and the rest on the other side. And in the final step, we can use one of the basic trigonometric identities to rewrite module of cosine x. In this manner, we ended up in the form where f with its argument is on the one side and the other side of the equation depends on this argument. Thus, the general form of this function can be written as the following. To be sure that our solution works, we can plug in the found function in the original equation and check it. As you can see, the right and the left sides are the same. Therefore, we did find a right form of a function.
Yes! 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 Yes!
As you have seen, sometimes even where there are no clues given, you can recall the fundamental definitions of the mathematical terms and use this information as a starting point.
That's how winning is done!
If you like this math problem, try to use similar approach to solve the same problem, but when there is no module for sine x in the original formulation. Feel free to post your solutions, ideas, comments, or just emotions in the comment section below. Your feedback does help to improve the channel and serves as a great support. And if you want to watch more videos like this, feel free to subscribe to the channel, allowing all notifications. In this manner, you will not miss new, cool videos about maths and neuroscience. And I hope to see you soon.